Hello, welcome to Beals Science. I'm Craig Beals and I've got a plasma ball out today because I like to do a bunch of activities with my students revolving around a plasma ball, but really teaching the concepts about electricity, about capacitors, and really making science exciting. And I want to share those with you today. So stick around while we have a little fun with electricity on Beals Science. Well, how does a plasma globe work? At the center of the globe is a high voltage electrode that has a very strong alternating voltage. Then there's a gas surrounding it. Now that alternating voltage at the center creates electromagnetic waves that course through the glass toward the outside of the globe. We're going to see if we can concentrate the area where the electrons are hanging out by building a simple capacitor out of pennies. Right now, that copper is building up with electrons. It's building up with electricity. So watch this. We should see it arc across to my finger. See that? I'm gonna grab a penny and you'll see it even better. Watch this. Look at that.
Oh, that is so awesome. Can I put my finger right here?
Kids are here helping me out today, and they heard me squealing about my burning finger.
Oh, God, Dad. Wow.
Smell.
How did you burn yourself? Why would you touch that?
Ow! Yeah, see?
Yeah,
Don't play with electricity,
Dad,
kids.
hold this. So the camera can go.
When I get out the plasma ball and teach about electricity, I like to spice it up a little bit, throw in some stories and a little bit of science magic. And one of the stories that I love to share with my students is the story that before I was a teacher, I was actually a Jedi, which none of it, of course, is true. And at this point, my students roll their eyes at me. And here's what would happen when you're a Jedi. Every morning, you'd wake up and you'd have to fill your lightsaber with the Force so that you could go and fight the dark side. We'd go, take our lightsaber, pull the Force into the lightsaber so that we could go out and fight the dark side with our light. Yeah. And at the end of the day, after you get done and you're going out and you're fighting the dark side, you got to put the Force back in so that it can replenish itself and be ready for you the next day. Oh, that's magic, people. Actually, it's not, it's science. Because you can see part of the problem, the reason I maybe wasn't such a successful Jedi, is that as soon as I walked away from the plasma ball or the Force, my lightsaber no longer worked. And of course, the other thing you're starting to figure out right about now is that's not a lightsaber, it's a fluorescent light out of the ceiling. But that doesn't make it any less cool. This is the same concept that we had with the pennies when they were stacked up there. Because we know we've got these electrons, this electrical field that's formed around the outside of this. The way we can prove that, of course, is with the pennies that we just did, but also with this tube of gas. You see, a fluorescent light works because electrons flow through the gas in the tube, they get excited and they light up, just like we see happening inside of this plasma ball. So all I have to do is get this close to the plasma ball, and it starts to glow. Well, why does it stop wherever my hands are then? Well, because my hands are a good path for electrons to get to the ground, to get to the earth. And the earth can hold a lot of electrons. So it's just an easy place for them to go. I'm gonna make a plasma ball, sort of, using this high-powered Tesla coil. It's used for checking welds and things like that, and just a regular old incandescent light bulb. Don't try this at home. It just gets you in trouble, me in trouble, and potentially gets you hurt. This is gonna be hard to see, but if you look at the very end of that thing, you can see purple. It's ionizing the air out here, and it's actually turning the air into a plasma, and you can smell it. It's making ozone as that high voltage electricity flows through the air like a lightning bolt in my hand. Hey, we got a helper in the lab today. This is my daughter Wrigley, and she's gonna shock me with this high voltage Tesla coil. And what I'm gonna do is I'm gonna take that light bulb that we talked about before. The electricity should flow up through here, inside the gases, and up really through my hand, but it'll flow around the outside of my hand. And this thing is gonna look just like our plasma ball. Ready, set, go. Okay, there you go. You see it? Do it again. Ah! Ow! That's the same thing that we saw with the plasma ball, right? Let's put all those pieces together. I'm gonna turn myself into a human lightning rod, and I'm gonna need them both to assist me. What do you think Mom's gonna say?
Stay alive.
Get a life?
Stay alive.
Mom, oh, stay alive?
Get alive.
Stay alive? Should we try this at home? Tell them.
No. No.
No, not safe. Don't try it at home. But we're gonna try it here at school.
It's a school.
Yeah, it's not at home.
But it's a school. Do you want kids?
This is a school of learning. This is a science classroom. This is where we learn and inspire. What? Should we turn off the cameras? Are they still on?
Yes.
That's awkward.
Or you.
This is a terrible idea from the beginning. But we'll be perfectly fine because I've done this many, many times in many venues. I've even done this on television for the news, the local news station, and nobody got hurt.
Luckily.
Yep, so here we go. Instead of me holding on to this, I'm gonna put this end on my tongue, and I'm gonna hold that end over there, and the electricity is gonna flow through my body, around my body, through my face, around my face, across my tongue, over there, into Rock's hand, and into the ground.
Wait, it's gonna go through my body?
Kill the lights! Here you go, I'm gonna put it on my tongue. When I make a noise, you're gonna have to put the juice to that, okay?
Okay, ready?
On this. Ah! Oh! You can see the light in my face?
Yeah, you could?
And this. We did it! Kids, I survived being a human lightning rod. How do we do?
Good.
Thank you for your help. And like we always say here at Beals Science, the kids ask if they could help me say this part. What do we say at the end of every little Beals Science video, guys?
Keep on learning.
Yeah, and thanks for watching. Good job, guys. Thanks for your help. Again, don't play with electricity at home. If you want to see just how horrifying it is when you get hit with high voltage electricity, I got shot with a police taser for science. Made a video of it. The description's down there. Check it out if you really want to know why you shouldn't play with electricity at home.